Hello everyone, I would like to welcome you to another AITS Tech Talk webinar. My name is Carla Girdi and I will be your host for today. Today's webinar will be presented by my colleague Munzir Karhani, who will take us through the two types of redundancy for application server, shedding the light on their advantages, configuration, and wrapping it up with a technical demo. Before we start, let me remind you to type any questions you have during the session in the question area, and we will answer them at the end of the session. Now let's get started. Hi Munzir.
Hi Carla, how are you today? Hi everyone. Thank you for attending this webinar. Today, as explained, we will talk about a very important feature in application server. We'll go straight to redundancy using the redundancy in application server, and this redundancy have two features. We can do redundancy through, we'll talk about the device integration redundancy, why we need it and what are the importance of it, and we will talk about the application engines redundancy. So first of all, let's start and go straight to our presentation, our webinar, and talk about the device integration redundancy. Why we need the device integration redundancy? In case we don't have this type of redundancy and I only have one communication with the PLC, as you know, if any miscommunication or we lose the communication with the PLC or the controller or the site, I will lose all the data. And this happened in many cases, especially we are in a smart city season now. We have a campaign about the smart city. We need redundant communication with different sites. So in case I don't have a redundancy, as I said, and the communication is stopped, I will lose data. So that's why we need this device integration redundancy, so that I can communicate with my site in two different ways. And this I can make sure that I always have the communication coming to my control room. So normally, to have this type of redundancy have many levels. We'll talk about the server level, the OI server level. In this case, I will have two OI server or OPC server or IO server. We already talked about this in a previous video, and we'll talk about it. Every server have maybe different protocol or different physical communication. And this is a real life scenario when if I'm connecting to, for example, a pump station using the GSM, and for a reason the GSM network failed down. In this case, I have to stay in contact. It's very critical. I might use another server to connect through, let's say, radio waves. So if I lose the first one, I can always get the other one. Let's go directly. As I said, it's a very practical and technical webinar. So in my demo, I have this scenario, this topology. I have a Galaxy repository, and the Galaxy repository as well, the engineering station, and this is where I will configure everything. I have two application servers. Where my application and the application object servers that host all my objects, and I have the communication driver that connect me to my controller or my PLC. I will use for this demo the Modbus protocol. Okay, so as I say, I'm using the cloud solution, 5 different virtual machine. I will use the GR platform, and in my platform, let me just go for full screen. In my platform, I have this Galaxy GR server, OI server 1, 2, and product platform 2. Let me say something that I already prepared the half of the redundancy of my application just for graphic reason, to not have time to prepare the graphics. And I will configure in front of you the other half. In my SMC, the System Platform Management Console, once to have the control and to remotely communicate everything, I need to install the driver on my engineering unit as well to remotely control everything. Now my primary OI server is actually the OI server 1. This is what I configured before, and I have the Modbus. This Modbus have a PLC. For more details about how to configure a driver, this we already talked about it in a different video. You can find it in our playlist in YouTube. So please subscribe, and we will put this link about communication driver in the chat box. So I want to just mention that we can have communication on PLC level. So I have PLC 1, and if I want to communicate using do some redundant on PLC level, I can add another PLC. Okay, so I have here two PLC. This in case I want a redundancy on PLC level again. So in this case, from configure, right click, and I have to add a redundant connection. Okay, let's say PLC1 is the primary and PLC2 is my secondary. Let's just do it. PLC2 is my secondary. So in this case, I will go for my redundant port, and only I have to do is choose, this is my PLC1, and this is my PLC2, which one is the primary, which one is the secondary. The device group, for sure, must to have the same topic name, and the device item, I have to import them. Ping item, that means this is the item from Orchestra or the application server that will ping the item. If it's not pingable, it's a switch from PLC1 to PLC2. This is generally how to make a redundancy base. Let me just make full screen. A redundancy based on a PLC. Now, this is not the case what I want to show you. No, cancel. I don't want to make any change. In my scenario, I want to make a redundancy based on OI server. So I have operating OI server 1 and OI server 2, two device integration. Now, we already talked before that we prefer that the OI server and the application object server to be on the same PC, so the same locally, I can read locally the data. But there might be a different scenarios regarding on the protocols, how many data I have. Maybe I need to make the OI server separated than application object server, and this is what I'm doing right now. So I have the primary OI server 1 and the secondary OI server 2. Put in your mind that both of them must, let's go and say this is port 1, PLC1 on OI server 1. We have to make the device group on the first OI server is same for the second one. So port 2, PLC2. Let's go for the device group, topic 1 as well. So both of them are linked to the same PLC through the same topic name, topic 1, topic 2. And this is very important to make the redundancy happen. So how to do it? As I said, I create a platform. This is not necessary. I can put, create or do the redundant I/O server or I/O client, the redundant device integration client, inside my application object server. But I prefer always the client and server to be on the same PC. This is why I create a platform for OI server. Same for OI server 2. So I have DDE SweetLink client here. And this will work the same if I'm using an OPC. So OI1 and OI2, this is the primary, this is the secondary. And I do have a prod platform with the redundant, but it's already prepared for the prod platform, the primary. I will do it for the secondary. How to make the primary and secondary is very simple. Go for template toolbox, right click, go for device integration. You'll find here something called redundant DI object. We do recommend to create a derived template first. Let's say that this is the G redundant IO, the global redundant object. And from the global, you have to, if you need some general script, you can put it here. So right click, new, and instance. Let's name it redundant IO2. This is for the object of the second product platform. As you see, there is a red X. That means there is a configuration error. It's not an error. I just need to put some configuration. It's very easy. Just click and drop, and that's it. So the primary device integration source, as I said, I want to choose the OI1. Just you have to choose which one is your primary and which one is your backup. And OI2 is my backup. Let's go for scan group. Remember, scan group is topic 1. So even click or write it topic 1. Or you can simply click on copy common scan groups. And this is important because only the common scan group or identical names in the OI1 and OI2, only the common one can be added to be a redundant topic. This is all what you need to do to configure your redundant object, DI object. Save and close. Okay. Now this object will be part of the AppEngine. And now I need to add the object of my AppEngines packaging heat exchange to this redundant IO. So this is why first I need to undeploy. Let's open view IO device, go to the OI where all these objects exist, drag and assign them to redundant IO2. You can drag and drop or right click assign to and change it to redundant. If you go for right click and right click, you can find assign to, but it needs to be undeployed. You can find IO redundant. This is the first one I already prepared, and I have redundant IO2. So go for IO2, and this is topic 1. Save, drag and drop, or right click assign to. Done. Happy with what you have. Why I put it on the AppEngine 2? Because it's locally. I need this object to read the data from this DI object locally. Right click and deploy the AppEngine. And okay. Now let's see the result. You can find I already prepared some animation. I will talk about the AppEngine later on the AppEngine redundancy. Here I want to focus on OI redundant. So this graphic already exists in your library. It's in the industrial graphic library under devices. You only need to put the name of your topic that you need to monitor. So I put this this device and a temperature to check the redundancy. So you can see which one is active, so which one is connected. Am I connected in general or not? Everything here is very clear. You can, let's say, softly force the failover to switch between OI1 and OI2. Or we can make a better test. So let me, for example, right now I'm connecting to OI1. So let me just disconnect the OI1. Which one? It's OI server 1, right click, deactivate, okay. Now it's disconnected, I'm connecting to OI2. And now it will show me why it switched, because it's disconnected. And what time it switched. The previous reason it was for force failover. So here you can see what's going on your driver. This is a very powerful, let's say, graphic to show you what's happened for the last switch and the switch before and what time, etc. And this is all about the redundant for device integration object, the device integration object redundancy. Let's go for another feature, which is the application engine redundancy. The application engine redundancy, as per the name, is the redundancy of my application itself. Normally, without the redundancy, the application object server, if I lose it or lose him, if I lose it, I will lose the communication, the process, the connection with InTouch, with Historian, with any device or any feature needed or any client needed to collect data from this server. That means I'm losing the application itself. When I'm saying application engine, that means I'm losing the application. So this is why this feature exists in my application server or in the system platform, when I can duplicate my resources, okay, and create a redundancy between the first server and second server. So if I lose the first server, automatically the application will shift to the second server, and nothing will be lost. So the primary server is lost, the backup server will take over. The switch between the server is very transparent to the client. The client will never see anything, even the historian server. The historian server, it will be very transparent. You will not know which one is sending the data. Is it the first server or the second server? So the application server redundancy here needs a specific networking. It's first we have to put in your mind that this type of redundancy is pairs only. So if you have an application server AppEngine 1 or application server 1 and 2 and 3, let's say platform 1, platform 2, and platform 3, and you want to make a redundancy of AppEngine 1 in AppEngine 2, so you already paired 1 and 2. You cannot put the third one into the consideration. Just all backup of 1 are in 2 and all backup of 2 are in 1. The terminology is like this. The configuration terminology, that means there will be a primary AppEngine and a backup AppEngine. You can talk to about them as partners. And the runtime terminology is different than configuration terminology. So the primary AppEngine can be active or standby, depends on the situation. When the AppEngine 1 is failed down, the AppEngine 1 backup will take over. But once the AppEngine 1 is alive again, it will be on standby, and the AppEngine 1 backup will stay on active. Now, in this case, if I have a load balance and I need that AppEngine 1 to stay active if it's alive, and the backup stay on standby, here I have to add a small script regarding the force failover. Once it's alive, make a failover and switch from the backup to the primary. Now, here we have to know that the RMC is very important to be very separated from the network. RMC and Orchestra, or let's say the application network and the RMC network, the redundant network, must to be separated. The redundant network is a peer-to-peer network. Why so to be separated and peer-to-peer? Because in synchronization, I have current data. The checkpoints must to be sent from active to standby or from primary to backup. A lot more actually active to standby. It depends on the configuration. I have alarm state and times will be always in synchronization. History stolen and forward blocks, deployed object and configuration, AppEngine status. All of these information must to be always synchronized between the active and standby. This type of data might make some traffic on the network. This is why the RMC network must to be separated peer-to-peer. And if you have, in this case, you have 2 network cards on every PC. So the first and most priority one is the application, and the RMC have second priority. This is how it's supposed to be configured, and this is how you must put it in your mind that different network, different subnets, is totally separated, different switch. This is our recommendation. Now, it's not only the configuration standby or primary backup from Win Platform 1 and Win Platform 2 is the one that is available, but as well the load balance. But the meaning of load balance, first we have to see it's a peer-to-peer architecture. So if I need to do some architecture, I have to use two machines. If I want to use two machines, in this case, I need to divide my application into two different machines so I can have a balanced application between two machines. I already talked about the performance and the calculation in a different video on our YouTube. You can find it on our playlist, or we will put the link on the chat box as well. So each Win platform, it will host a different app engine and the backup of the other app engine. So the backup of AppEngine 1 is assigned to node 2, and the backup of AppEngine 2 is assigned to 1. This will make a balance of my application. It will balance the load, and it's a peer-to-peer. And I'm 100% sure that my performance must be and will be okay. So in my calculation, I have to put in my mind, and for example, this scenario, I have to make in my calculation that my machine must to support two app engines, not only one, the primary and the backup of the other one. Once the other one is alive, as I said, we can put it back using a script. So in my consideration to make the redundancy configuration, first we have to make the networking. So we have to install a second network card, configure the connection to access before the RMC configuration. As I said, we need the application network to be in priority, and give a fixed IP for the RMC. For this network configuration, the Windows networking, after the webinar, we will send you a newsletter, a technical newsletter, how to configure on Windows your network card and your Windows networking. After finishing with Windows networking, I need to do the application server, which is very straightforward and very easy. Only you need to configure first your Win platform, the platform itself. You have to put the IP address of your redundant IP address. And second, you have to configure the application to be redundant, and then assign the right app engine, primary or backup, to the right Win platform. Again, this is the same demo that we want to do. Only I have the two app engine I need to create, or I want to configure the redundancy from these two application object servers. Let's go for it. It's same here. Download, okay. So I have prod platform. This is my node 1, and this is my node 2. And I already configured the AppEngine 1 as my primary and put the backup in AppEngine 2. I will do the same for the product platform too. So first, as I said, we have to put the IP address of the RMC. Open the platform. You can go down, and you'll find redundancy, local redundant message IP address. So you put the IP address of the network card, the redundancy network card, or the network card that is will manage the redundancy of the platform itself. So the first one, I think, is 192. I'm using a dynamic. But if I want to elaborate more, it's 192.168.1.13, and the redundant network is 10.1.1.13. Totally different network, different subnet. Okay, and same for the partner. The partner is 12 instead of 13 in my case. Let me close. That's once you put the redundant, save and close. I don't have anything to save in my case. Then the app engine, just double click. You can do it, this part, from the derived template or from the instance. But if you want to do it from derived template, make sure to different derived template, one for redundant app engine and one for non-redundant app engine. And then you can control the redundant from all the redundant engines from the template. From my case, I will do it from the instance. Double click, open the app engine, simply go for redundancy, check enable redundancy, and here you can have some parameters you can control. So force failover timeout, standby engine, etc. You can do whatever you want here. You can change the parameter. Once you're happy with it, save and close. I'll keep everything as default. Yes, my bad. So what I need to do first, let me undo checkout. First, we need to undeploy everything before doing this part. Why? I'll tell you why, because this part is very critical for the deployment. Close, and let's double click, do it again, go for redundancy, enable redundancy, and save. Okay. You see automatically the icon will change. That's mean now it's green. That means I have a backup. The backup is unassigned. So put it in the node one, the partner. Just drag and drop or right click assign to. That's it. Then how to deploy, especially at the first time you want to deploy your app engines, go for your primary app engine, right click, deploy, and do not miss to include redundant partner. You have to include this one. Now, if you have a big big application, like 20,000 of objects, 50,000, 100,000, 500,000 of objects, and you have a big numbers of engines, etc. It's better to not cascade the deployment from the app engine. That means let's deploy the app engine by itself first, then you can deploy area by area. But this is only when you have a very heavy application. In my case, I don't need to do this because I have a small application. So I will cascade everything and all objects will be deployed at the same time. Because it's an app engine, it will take a little bit of time more than a normal object because the app engine is actually my application. It will affect the CPU, the RAM, etc. So in my calculation, I have to put all of them in my mind. So successful, everything's fine. Now, I would like just to elaborate something. In my primary here, line 1, I have mixer 100 and temperature 001. This is the one that I'm looking in my graphic. So right now I'm looking at AppEngine 1. It's already the same, but I just prepared before. I don't want to put the graphic and take more time on it. So you can even force the failover. This is the primary one. So switching to standby. Now it's ready, but the active one exists on platform 2. That means if you go to my application on platform 2, right now I have the app engine and the backup are working at the same time. You can see this one from the SMC. If you go for your SMC, go for platform manager. It's another view. Go for platform manager. Let's go for here. Go for platform 2. So you can see this is the running on scan, both of them, the app engine backup and the app engine 2, the primary. And the partner is actually on standby. So it's on standby. You can see it's ready. The partner is ready. You can see all this information instead of looking at it from SMC for operators, for example, the same graphic that I'm putting here. Where to find those two graphics? Again, you can find them in your graphic toolbox. Let's go for graphic toolbox in here. And situational awareness, no, not situational awareness, sorry, my bad. You can go for industrial graphics library and you'll find a display. Those are the display, the AppEngine redundancy, DDE SuiteLink client, DDE redundancy, all these and more. You can find them in the display folder. Just you need to change a little bit in custom properties. Now I'll do this exercise from, let's see, just the application, which one is working, the platform 2, this one is active. So let me just turn off this PC. same, it will be turned off. No, this one will not work. It's different PC. So let me go and turn off my my platform. Go for redundancy. This prod platform 2. Simply, I will shut down for shutdown. This is the prod platform 2. Let me go to my graphics again. It might take a little bit of time. Just now it's unknown. I'm switching standby but not available. This one is active. Now the prod platform, the primary, is active, and the partner, you can see active. This is the primary. The partner is standby but not available. Why? It doesn't exist. This is why. And that will be all about the redundancy for both device integration and the application engine. So please, if there is any question, I'll be more than happy to answer them.
Thank you, Munzir, for this informative session. As mentioned earlier, we will give our audience a few seconds to send their questions. Meanwhile, I would like to invite you all to follow us on our social media platforms to stay up to date with our latest news and webinars. I'm sharing with you now the links in the chat box. All right, let me start reading the first question we received. Munzir, someone is asking, what about the redundancy for historian server?
Good question. Now, historian server, yes, it is part of the redundancy of historian server, or the historian server is part of system platform, but it's not the application server. Now, regarding historian server, let me go for, because it's already open, and I already have a historian server. How to do a redundancy for historian server? Simply go, everything will be done from SMC. So go for SMC, open your historian, go for, let's just give it a time. The difference between historian server redundancy and application server both redundancy is like this. First, those features are application server or AppEngine redundancy and the OI server redundancy as redundancy are part of the application server. That means you don't need anything to buy. You just need to to double your resource. Instead one machine, you need two machines. For the OI servers, you need a license for every OI server, and already the system platform came and designed for this type of redundancy, so generally no need to buy anything more. But regarding the historian servers redundancy, first, how to do the redundancy is not from the IDE. You have to go for configuration editor, system configuration, go for parameters, and you have to go here. There is something called a partner. You have to search for it. Something here called partner, and you have to put the partner historian redundancy from the configuration. Put the IP address or the computer name of the partner, and everything you do in the configuration must to replicate it in the partner. So if you change, for example, the group private names from 1 to 2, you have to do it on the other. So this is why it's very straight. You have whatever you are doing on the primary, you have to do it on the partner. Only change the name of the partner. So historian server 1 here, the partner historian server 2. It's somewhere here. I have to search for it. It's between those partner. Can we check here? Where is it? The partner? It's somewhere here. Application, no, the partner. I'm just not looking. Historian, something called partner. Anyway, just have to put the name of your partner. But it's not for free. That means you have to buy another historian. Well, actually, you have to buy a license for historian redundancy to apply this configuration. I think if I explained well this part.
Okay, thank you, Munzir. Another question, how can I reduce the downtime impact, sorry.
Okay, this is a very good question. If I understood well, that means that time to switch between a server to another server. Let me go back to my. Now, regarding the device integration, it depends on the network and how fast I'm connecting to the field. But if you're asking about the AppEngine, as I explained here, you have to make sure that you are well calculating your resources, because more heavy you're putting on your application server, more time it will need to switch between a server to a server. Now, if you need a high availability, that means you cannot tolerate more than 1 second switching between a server to another server. Or you are talking about let's say disaster recovery. That means if the site fell down and you need another site to take over it. And in smart city, this is very critical. In this case, an application redundancy is not enough. This is where you have to go for another solutions. And we have two actually, Stratos and we have ArcServe. So in this case, you have even to check Stratos, the fault tolerance of Stratos, Evaran for disaster recovery, or ZTC for edge. And I think we have an upcoming event about Stratos for smart cities, if I'm not wrong, very soon. Or ArcServe, that they have the solution for backup and high availability as well, or disaster recovery. So it's totally different solution if you really need a high availability, fault tolerance, or disaster recovery. Other than this, to reduce, it's all based on the resources, some calculation of CPU RAM versus the number of application engines. Yep.
All right, thank you, Munzer. And yes, we will be having a webinar for Smart City on April 6th. All right, moving forward with the questions, we have another question. If we have OPC servers like Kepware, Matricon, OFS instead of device integration, then what difference will be in configuration?
Great. Let me go to the demo and show it in front of you. So in my demo, actually what I configured already is those, I already prepared the clients, yeah, and put redundant object for every client, for both of them. So let me just put it here. So this is the redundant object, and I have, this is my primary, and this is the secondary. If you have an OPC, so that's mean, again, go and look at how to what is the driver, part one. We already make the webinar about the driver. I explained different types of drivers, the DI object, the OI objects, the drivers, OI server, IO server, and what's the difference. If you have an OPC server, forget about the SMC. In this case, you have OPC client. So instead of OI1, which is a DDE Sweet Link, it will be OI1 as OPC client 1, and this is the OPC client 2. And the same way you configure the redundancy, OPC client 1 and OPC client 2. The one is primary and the second one is secondary. Same way.
Okay, perfect, Munzer. Another question from Amit. What is the switchover time? Is it bumpless totally, or we have to lose data for 1 or 2 seconds?
Okay, yeah, this is the same question regarding the timing. It's all depend on your network, the hardware, your resources. This is all depends on all these factors together. So if you are reading from a site using, for example, let's say the device integration. If you are reading from using optical communication, okay, it's faster than radio wave. So if you lose the optic communication, it will take few seconds, maybe few minutes to shift from one to another. Same for the app engines. App engines here, as I show you in the demo, it didn't take even seconds. It's not even 1 second. It's like click. I only fail it down, I open it, and it's there. That's because the communication in my environment, it's all virtual machine. There is a fast communication between every machine and another, and it's a light communication. It's a light application. Now, if you have a heavy application with a complicated network and switches and redundant switches, etc., more complicated and heavier, this will take more time to shift between a server to another. One of the project I saw shifting from a project to another can take up to 10 to 15 minutes. If it's not critical, it's okay. But in this project, the object, I mean the machine or the server was very heavy with a lots of number um, app engines. This is why you have to optimize the number of app engines, optimize your application, and it will be faster and lighter. Again, you need a high availability. You need to reduce it within a few seconds, not more. You cannot tolerate any loss of data. Then you have to go for another solution if you have a heavy application.
Okay, Munzir, we have another question from Abdulrahman. Is there any difference to make redundancy with InTouch instead of Orchestra?
Yes, a huge difference between InTouch and the system platform. System platform is a system of platforms. When you have a client-server relationship, so if you lose your client, it's very easy. Just you have another client. In InTouch, it's an HMI standalone. You don't have actually a real redundancy in InTouch. What you have in InTouch is what we call it a hot backup or a primary, secondary. You have somehow a redundancy linked to the device integration redundancy. It's almost similar when you are in access name. You can once you are creating an access name, you can create a primary access name and secondary access name. Within the access name, primary communication and secondary communication, and the access name will work exactly like the device integrations client, the one that I explained, but in InTouch. For this part, there is redundancy, but when you are talking about an application redundancy, InTouch is actually an HMI. So if you lose this HMI, you have to distribute another one from the engine. Totally different application where there is no client-server relationship, so there is no redundancy for servers. But you can have, as I said, hot backup for the alarms, and you can have redundancy for the device integrations, and you can make the HMI. You can duplicate your HMI on different monitors to not lose any of them.
Munzir. Ahmed
Yeah.
is asking, is there any replication between application server, I mean database stable replication? During failure, how do we check if there is no data lost?
Could you please repeat the question again?
Yes. So is there any replication between application server, I mean database stable replication?
Yes.
During
Yes.
failure, how do we check if there's no data lost?
Well, actually, there is an automatic, as I explained, automatic synchronization. So automatically, it's not between application server, but between engine. At that dot, every engine is synchronizing with its partner for all the important data. That's mean current data, the alarms, history, etc., deployment object, and app engine. This is why the RMC is very important, and it must to be separated because all this data and all this replication will be synchronized. So I think this is, if I understand well, this is what the answer is. If not, please let me know and I can elaborate more.
Okay. Okay. Another question from Boogie. Please explain how disaster recovery scenario is configured.
Okay, disaster recovery is not part of the application engine redundancy. It's not part of this redundancy. Disaster recovery, first, what is disaster recovery? If I have one site with control room, let me put it here, one site with a control room. When the control room have been, let's say, on fire, a fire happens. So the whole site will be filled down. Disaster recovery, that means I have a replicated site. If the first site fell down, the second site will take over. Different site, geographically different. Now, can we do it with an application with application engine redundancy? Somehow, yes, but it will be very difficult due to the communication. We can put an AppEngine in a site and another AppEngine in another site, but it will be a headache for to manage and to, I think, to keep on the communication between two sites. Doable, but it's for a real disaster recovery, we have other solutions like Everrun from Stratos and ArcServe. When it's made for this type of disaster recovery, the whole site, as all VMs, will be replicated in another site. If the first site, site A, this means here I'm making a redundant site. The first site failed down, the other site will take over in almost no time. In almost no time. This is where the disaster recovery will take over. I think the maximum 1 minute. Here, I think they can, in Strato, they can talk about it more. A few seconds to 1 minute, the site one, all of it is failed down, the site two will take over. But this is, as I said, a different, totally different solution.
Great. Okay, Manzir, another question. What is the specification of RMC link?
The specification of RMC, first, it's a peer-to-peer. It's supposed to be on a different network, different switch, different subnet IP, totally separated. This is the only, and yeah, faster is better. So 10 meg is better than 1 meg, and 100 meg is better than 10 meg. That's it. And yeah, one more, the IP address for RMC must to be fixed, and we have to remove the DNS. We will send the newsletter about this part after the webinar.
Okay. And finally, Abdulrahman is asking us, if we just configure redundant in SMC, everything will be okay with InTouch, that's between the two devices working together, clear?
Here, there is, for redundancy, there is many level of redundancy. If you configure redundancy on SMC, that means you're doing redundancy between two PLCs, PLC 1 and PLC 2, as I was showing here. Let me go back. And I will go for SMC. So what you can do in SMC, let's just reduce it here. You have in one OI server, one port, you have a PLC with an IP address and another PLC with different IP address. Could be one PLC with two different communication. Yes, could be communication mode. So if you do it this way, then you can put the redundancy, and in this case, you are doing redundancy from the field. Now, to do the redundancy of communication, you need to create OI MBTCP1 and OI MBTCP2, different servers. And from InTouch, the question is InTouch. From InTouch, we don't have time, but I can open it and show it. You can go for access name, and in access name, there is an option for primary and secondary. So you have to configure both. So the primary will be connected to OI1, and the secondary will be connected from OI2. This is from access name. Once you create the communication with your SMC.
Okay, we have another question.
Great.
Well, this question is indirectly related topic. If you have the two historian, how to do historian redundancy with server 1 and server 2? It may need any software or by configuration can be possible.
Yes, you need to install historian on server 1 and server 2. This is one. You install server 1 historian and server 2, both of them. Then for server 1 and server 2, both of them, you go for the configuration editor. So this is here, there is a server. Let's say this is server 1. Go for system configuration parameters. And I really want to know, because here the is small system partner. There is something called here partner. Historian partner or something partner. When from historian 1, this is historian 1, you put OK, replication, not the replication. Historian 1, you put the name of historian 2, and in historian 2, you put the name of historian 1 as a partner. There is here something called partner, I think. And this is how you do it from configuration, but you have to install here and there. And you need a license for it. license as redundant license. So first license for the historian, the second license for redundant license.
Okay, Munzir, thank you.
I found it. Historian partner. So you go here, double click. This is the name. You put the name of the partner machine, the other historian. You put here where is my partner, and you go there and you put the partner here. But remember, again, for historian, all the configuration must be replicated here and there. The same configuration for historian 1 must be replicated for historian 2. Yep.
Okay, Munzir, thank you. Ashraf Hani is asking about the webinar recording. It will be uploaded on all our social media platforms today, and also we will send it to your email addresses as well. So that's it with the questions. I hope we answered all your questions clearly. Finally, I would like to thank you, Munzir, for this interesting session, and to thank you all for attending our Tech Talk webinar.
Thank you, Carla. And for any question, please do not hesitate to contact us. Thank you and have a nice day.
Bye-bye.